Students, let's look at this question which is on sequence and series second from the year 2007, paper 2, question 2. But I think this is a modified question. So a sequence U1, U2, U3 is such that U1 is 1, and it's given that UN is given by this 1 over n squared. We asked to evaluate this over here. This guy over here is actually this guy. So just understand that in our syllabus, there's either AP, GP, or method of difference. So this case is definitely method of difference. What I need to do is actually just rewrite this n equals to 1 to n plus 1 over n squared plus 1 squared. So this would just be, if I rearrange it, it's just un minus un plus 1. All right. So this case, again, is u1 minus u2 plus u2 minus u3 plus u3 minus u4, all the way to the last few terms, un minus 2, maybe un minus 1 plus un, capital Un, minus 1 un, then plus un minus un plus 1. Okay, so this case here, once we're done, we will get u2, then just cancel it out. Great. So this case, what I'm gonna get is left with n, summation of n, and n equals to 1 u1 minus un plus 1. Okay. Oh, sorry. Oh, sorry. Just left with these two of them. What am I writing? u1 minus un plus 1. Then once this is done, we're gonna use this. U1 is 1. There's 1. And this would just be un plus 1, just un plus 1 square. 1 over n plus 1 square. Okay. Shouldn't be an issue. First part. Second part, give a reason why convergent and states the sum to infinity. So part 2. Sorry, this is I. Part 1 is convergent. So you want part 1 is convergent since as n goes to infinity, we know that 1 over n plus 1 square goes 0. So hence the summation series n equals to 1 to 2n plus 1 over n square n plus 1 square will tend to 1 minus 1 0 plus 1 square. 0, 1 minus 0. So hence series is convergent. And sum to infinity is 1. Great, done. So let's look at part 3. Use the answer to find this. Okay, I'm just gonna do this. Similarly, this is use the answer in part 1 to find this summation here. So this case, I want to show this guy here. Firstly, we need 2n minus 1 square here. So firstly, we need to change the just understand. We need to change this guy to this guy. Okay, so the UR term we need to change. So replace R with maybe we can see that it's replacing R with to get n plus 1, replace R with n plus 1, right? So replace R with n, or rather n, with n plus 1. Okay, replace it so that we get this. So when you replace n plus 1, then what you get is, this is n. This is 2. This n plus 1 equals to 2. N plus 1 equals n. Just remember that when you replace this n as well. And also there's the invisible n here. Just replace it. Okay? Important. Then once you're done, the top will be 2. N plus 1 minus 1. N plus 1 square. N plus 1 minus 1 square. So simplify it. It'll be n minus 1. And this will be n equals to 1. That just will be 2n. 2n plus 1. Okay, that's 2n plus 1. This is n square, n plus 1 square. Is that the same? So you see that this will be n to n plus minus 1. So this case here is the same, right? It's exactly the same, except that this is n minus 1. So if I want to change this, I want to find 1 to n minus 1. I just need to replace n with n minus 1. So this guy will be just 1 minus of 1 plus, just replace n with n minus 1, n minus 1 plus 1 square. That will give us 1 minus n square. shown. Okay, or not shown. That's it. That's the answer. So that's how we do this question proficiently. If you have any questions at all, please let us know. I'll see you in the next question.